So this is the JEE Advanced problem that we will try to solve. We have already given one solution, the simpler solution, which does not use the special trick that we will be discussing here. And the special trick is actually this. So it says that if I reflect the orthocenter of a circle, so this is a circle in which I have the orthocenter as h. Orthocenter is of course the point at which all the altitudes of the triangle meet. Now this point H, if I reflect it along this side BC, now what does reflection mean? Reflection means that this line HBHO has been extended by the same distance in the downward direction and we reach this point X. So this X is the reflection of H alongside BC. Now this X, the property is the orthocenter reflection property. What does it say? It says that this X would lie on the circumcircle. Now using this particular property, we are going to solve this problem. As I said, if you have not used this property and are able to solve this problem using basic principles, that is actually preferable. That is the better and simpler method. But I want to illustrate this particular sort of theorem, how to apply this particular theorem in solving coordinate geometry, and that is why I am going to solve this problem using this orthocenter reflection method. So let's just use it, okay? But like I said, in the real exam, you don't have to. So here is my graph of this problem. Okay, so we'll start with the graph in this case. So what we are saying is that one of the sides of the triangle lies along the line y equal to 0. The second side of this, our triangle, lies along this line, which is x plus y plus 1 is equal to 0. The two lines intersect at this point, and this point is our first point, the first vertex, and the first point which passes through the circumcircle. To determine the equation of the circle, we need 3 points. So this would be our first point, the vertex. The circumcircle would of course pass through the vertex. So y equal to 0 will substitute here. So of course y will be 0 and x will come out to be minus 1. So that is our first point. Now let's look at the orthocenter. So orthocenter is at point 1, 1. Now we'll use the reflections, our reflections of the orthocenter. So if we reflect the point 1, 1 along this side of the triangle, so y equal to 0 is one of the sides. So we are reflecting it along this line. It is the simpler one. So the reflection would come out to be, the x would remain the same and y would turn out to be, from 1 it will become minus 1. That is the reflection. So orthocenter has been reflected along one line. Now we'll reflect the orthocenter along the second line. So this is our second line, okay, along which we are trying to do the reflection, and our reflection point, let this be x. So we are reflecting along this line, this orthocenter. Now how do I do the reflection? First I have to determine the equation of this line, which I know is perpendicular to line x plus y plus 1 is equal to 0. By using the slope method, we can say that this line would be of the form x minus y plus c is equal to 0. This line, okay, this line I am talking about, which passes through the orthocenter 1, 1. It will be of this form because it's perpendicular to this line x plus y plus 1 is equal to 0. So I just change the slope from 1 to minus 1. That's the negative reciprocal. So from here I also know that this line should pass through 1, 1, which means that 1 minus 1 plus c should be equal to 0, or the equation of this line c, which means that c is actually equal to 0, which means that the equation of this line comes out to be x is equal to y. So that is the equation of the line. Now the equation of this line turned out to be very, very simple, which is good. Now all we need to do to find this point is to actually find the intersection of this line and this line x plus y plus 1. So let's just do that. So we are finding the intersection of x is equal to y and x plus y is equal to 1. So I substitute x is equal to y here. So this becomes 2y is equal to x plus y plus 1 is equal to 0, or 2y is equal to minus 1, or y comes out to be minus half, and x will also come out to be the same thing, minus half. So this point becomes minus half comma minus half. So the difference in x coordinate as I go from this point, let's call this point O, as I go from O to my orthocenter is 1.5. So I need to move the same distance to reach in the negative direction to reach x. So I'll decrease 1.5 from this one and I'll get -2, and I'll decrease 1.5 from this one and I'll get -2. Okay. So this technique we can use because the points lie on the line x is equal to y. If they were on some other line, then we will actually really have to calculate the distance between 1, 1 and -half and then do it. Okay, but because the points are on this special line x is equal to y, therefore we can we need to go the same distance to reach x as we need to go to reach 1, 1. Okay, that is the location of the point O. So the point O is equidistant from point x and the orthocenter. So to find x, either in this special case, I can just use the x and y coordinate. I can subtract the values and get to the point x. But otherwise, we would really have to calculate the distance and then find out the point x. That's why I'm saying that doing this reflection method, although we are doing it here, but it is not the simplest way to solve this problem, and actually it is not the recommended way at all, because there are a lot of scope for making mistakes. In the same channel, on the same channel, we have solved it using a much simpler technique, which is just using the basic principles actually. So now we have found out the 3 points -2, -2, 1, -1, and our third point being the vertex -1, 0. These 3 points are the points through which our circumcircle passes. So let us just write the general equation of the circle: x square plus y square plus ax plus by plus c is equal to 0. And this circle passes through the 3 points -1, 0, and the second one is 1, -1, and the third one is -2, -2. Okay, so we have 3 equations, 3 unknowns. We can solve it. So let's just do that. So first I'll substitute -1, 0 here. So this becomes 1 and plus 0 minus a plus then b, this will become 0. C is equal to 0, which means that a is equal to c plus 1. So that is our first equation. Now we substitute 1 minus 1 in this one. So what do we get? We get 1 plus 1 minus a, okay, because that is what we will get. A will be plus 1 plus a minus b plus c is equal to 0. If I am substituting this, the second point in our original equation, so that becomes a minus b plus c is equal to 0, and this is of course 2 plus a is c plus 1, c plus 1 minus b plus c is equal to 0. Now from here I can say b is equal to 2c, this is c plus c, 2c plus 3. Okay, now I come on to my third equation. Third equation I'll get from this point, 2 and 2. So let's just calculate our third equation. This will become, I substitute minus 2, so this becomes 4 plus 4, and this becomes minus 2a and minus 2b plus c is equal to 0. Now I substitute a in terms of cc. It is cumbersome, okay, but nonetheless we have to do it because that is the path we have chosen. Now once you are committed so much on a method, then we need to stick to that method. We cannot do anything else. Minus 2, so better start with the simpler method first. Okay, so this has to be 2 plus 3c. I forgot, sorry, this is c plus c, this is 2c plus 3. Then this becomes 2c plus 3 plus c is equal to 0. So if you notice, this will be 8. From here I will get minus 2, and from here I will get minus 6, which means that my c, if I solve this equation, this will become the constant terms will evaluate to 0, which means my c will turn out to be 0. Okay, that is what the first thing I'll find from here. Now because my c has turned out to be 0, I can now simply find the value of b as 3, substitute c, okay, then nothing else. And in this equation I substitute c, I get a as 1. So my final equation for this circle becomes x square plus y square plus x plus 3y is equal to 0. Of course, we have solved it using the reflection of orthocenter technique, but finding reflections we have seen is troublesome, is cumbersome. So if you had solved this problem using the basic principles as we had done in another class, you would have been better off. You could compare this solution with that solution and you will find that this is that one is much simpler, this is more complicated. Okay, thank you very much.